So now we need to start talking about frequency tables and how to display our data. We've talked about collecting data. We've talked about what data is, what kind of studies there are, what kind of data we're collecting. So when we collect the data, we have to display the data. So we start with frequency tables first. The first column in a frequency table lists all the different classes or possible bins of each set of data. The second column will list the frequency of each category, which is the number of data values in the category. The third column lists out the relative frequency. The relative frequency has a formula. This is its lovely formula. Yes, you do need to know it. We don't give it to you any other place. You find the relative frequency by taking the frequency of that particular category and dividing it by the total one. You'll get lots of practice, don't worry. And then the fourth column lists out the cumulative frequency. Which is the number of responses in a particular category in all the preceding categories. So let's get some practice and actually see one in practice. If you look at example 2, it says a teacher makes the following list of grades she gave to her 30 students on a test. Construct a frequency table for the grades. So in the first column, you have all the different grades that are possible. These were the classes or the bins. They are A's, B's, C's, D's, and F's. Those are all the different grades that are possible. In the second column, we have the frequency, which is how often they got those grades. So how many A's did we end up with? Well, we got 6 of them. How many B's did we end up with? Well, there are 6 of those. How many C's do we end up with? 10 of those. And D's? 5 D's and 3 F's. For a total of 30. Which is good. I knew we needed 30 because it told me there were 30 people in the class. So far, so good. Piece of cake. The relative frequency is when I take the frequency for this, that's the 6, and I put it over the total frequency, which is 30. And I do my division. So 6 divided by 30 in my handy dandy calculator. Not the one you're used to. I got like 7 different calculators in this house right now. But this is the one that's right here, and we have no power for it. So we're going to go to the next handy dandy calculator. I know what it is, but I wanted to get a calculator for you. Okay, fine. Be that way. We'll get the one for you. This one. I am here. So 6 divided by 30, enter. Gives me 0.2 times the 100 because relative frequency is a percent. And you get 20%. Done. Next, it's another 6. So that's going to be another 6 over 30. Which is going to give me the same 0.2 times 100, which is going to give me the same 20%. The next one is 10 over 30, which gives me the 0.33 repeating times 100 equals 33.3%. The next one is 5 over 30. One 1.6. Sorry, not 1.6. 0.16. Repeating times 100 equals 16.7%. And then the 3 over 30. %. If you add all of these up, yes, you really do get 100. You need to be able to add all of those up and get your 100. If you don't add all of those up to get your 100, there's going to be an issue. I'm explaining this to you. That's a way of checking your work. You want to be sure that when you add all of these percentages up, you end up with 100%. That's one way to check your work. Just like getting the 30 here is a way to check your work up there. Cumulative frequency starts with this frequency here. We start with our 6. Then the next one says we have 6 here. We add the number above. So 6 plus 6 equals, my cumulative frequency is 12. Then I take this number, 10, and I add every number above. So 10 plus the 12, because that was every number above, is going to give me 22. I take the 5, I add it to the number above, that gives me the 27. I take the 3, I add it to the number above, that gives me the 30. My math lab is going to want you to write 30 again here. I don't know why. It makes absolutely no logical sense, but that's what they want there. They want the 30 here, they want it here, and they want it here in all three places. Same number, all three places, every time. No matter what that number happens to be, it's going to be the same number in all three places, just like that one's always going to be 100. So please make sure you follow those specific rules for my math lab. That'll save you a lot of trouble. Your real big question should be, are we going to have one of these on the test? Oh, you not only have one on the test, you have one on the final, one on the midterm. It shows up. Okay, you don't have one on the midterm because this is past the midterm. But you have one on the test, you have one on the final. Just wanted you to know. It's there. Binning data. Binning data is what happens when we deal with cumulative data categories. It's often, quantitative data categories. It's often used to group or bin the data into categories that cover a range of possible values. You need to make sure that your bins should be the same size. All the time. So in the next one, they said they wanted us to use 5-point bins, and they went ahead and started us with some bins. They said we're going to do 95 to 99, 90 to 94, which means my next group must be 85 to 89, 80 to 84, because those are 5 numbers, 80 to 84, 80, 81, 82, 83, 84. 5 numbers, because you actually count the 80. And then you have 75 to 79, 70 to 74, 65 to 69, 60 to 64. Then they want to know what the frequency is, and they give you all of these numbers up here. So you get to pause the video and go ahead and put in the frequencies, and we'll see if your frequencies end up being my frequencies. So the question is this what you got or not? I put all the symbols down for all the numbers that I have up here and where they go. Including the one with no symbols. So for the relative frequency, we have a total of 20, so 3 over 20 equals 0.15, which is 15%. 2 over 20 equals 0.10, which is 10%. 3 over 20 equals 0.15, which is 15% again. 2 over 20 we figured out already, which is 10%. 4 over 20, we haven't done that one yet. That's 0.20, that's 20%. Then 1 over 20, 0.05, that's 5%. 3 over 20 we said was 15% again. And then 2 over 20 we said was 10% again. And once again, this has to add up to our 100%. Cumulative frequency, we start out with a 3, and then I have my 3 plus 2 this time. Gives me a 5. And then I have 5 plus 3 this time. Gives me an 8. And then I have 8 plus 2 this time. Gives me a 10. Then I have 10 plus 4 this time. Gives me a 14. Then I have 14 plus 1 this time. Gives me a 15. 15 plus 3 gives me an 18. 18 plus 2 gives me a 20. Understand that you're only putting in this very last column. You know, these numbers are all that we're putting in. Just like the percentages are all that you're putting in. You don't have to put in the calculations into MyMathLab. They just want the answers. I'm just showing you how to get the answers. And then they want the 20. They're going to want the 20 here. Just like I told you, they're going to want this one. And they're going to want that one. And they're going to want that one. Just like they want that 100 there. But I wanted you to understand how to get all those numbers. Okay. Those are frequency tables. I'll see you in the next one.